Let us continue. We reach up to here. Torque is equal to P sin theta. So what is theta? Angle between dipole moment vector P and electric field vector E. What are the maximum and minimum values? Simple. When theta is 90, sin 90 is going to be 1. So torque is going to be PE is maximum. So what is the maximum torque? PE. Even without any discussion, we will be able to follow in the equation PE sin theta. Maximum value of sin theta is 1. Therefore, maximum torque is P. That point is understood. Maximum torque acting will be P. What is the situation? The situation is illustrated here. I am having the electric dipole. Dipole moment is shown and electric field, they are perpendicular to each other. Both are going to be perpendicular. Then the maximum torque will be acting. That means it will not remain there, it will be rotating. Which will rotate, our dipole will rotate. Then when theta is 0 or 180 degree, sin theta is going to be 0. So what is going to be the torque? PE sin theta will become 0, is going to be minimum. Look at the situation. When the electric field and dipole moment both are parallel to each other. In our diagram, electric field was up, dipole also parallel to that. Then torque acting is 0 means it will be at rest. We use the scientific language, the dipole will be in equilibrium. So when is the dipole in equilibrium? In uniform electric field, when theta is 0. In a sentence, when electric field is parallel to the dipole moment or dipole moment is parallel to the electric field, any order, the torque acting is 0, so it will be at rest. When it is in opposite direction, anti-parallel, then also it is going to be, the torque acting will be 0. So that part is over. Now what will happen if the electric field is not uniform? Not uniform means what? This was our dipole. The force acting on this, the electric field at this end and electric field at this end are going to be same. So that is one is plus QE and another is minus QE. Total force is 0. That is why it is not moving. But in non-uniform field means one side electric field may be E1, other side electric field may be E2. Maybe this is the charge, positive charge, and the electric field there is E1, this is our dipole. In our diagram, let us assume this is going to be our dipole. Sorry, just argument sake, this is going to be our dipole. The length of the dipole is 2a. This is going to be the dipole moment vector. The force acting on this will be plus QE1 and the force acting on this will be minus QE2. Electric fields are not same, then the force will not be 0. In such a case, what we call it will be moving plus it will be rotating. There will be both force and the torque. Repeat. Non-uniform field means electric field is not uniform. Example, electric field here may be 10 Newton per coulomb. Maybe this here it may be not 10, it may be 9 Newton per coulomb. Example. So the force acting this side, that will be plus Q into 10. Here it will be minus Q into 9. They are not equal. So what will happen in non-uniform field? The dipole will have force as well as torque. It used to be asked for the board type as well as CET 3-4 times in the past question papers. In uniform electric field, no force, only torque. In non-uniform field, there will be both force and torque. That point is conveyed. Finally, when what we want to convey, electric dipole, the direction we have seen, direction is going to be perpendicular to the vectors P and T. Perpendicular to the vector P and T. That one also we understood. So that part for page number 13. Now we go for the very short derivation of 2 steps from page number 16. Why we jump suddenly to page 16? Because the derivation is short and we are not introducing any lengthy ones. Look at the title, page number 16. Electric field due to a charged plane sheet. That means a chain, what we call a plane plate, we can say. Example, this is a book, just for argument's sake, I am just showing. Assume it is a plate and it is charged one. It may be positively, it is having some thickness. It may be positively charged or negatively charged. Maybe when I am charging it, charges will be present on right side as well as left side. We assume it is infinitely low. This is not infinitely low. This is having only, let us say, 40 centimeter length. But in our example was infinitely low charge sheet we are considering. We are considering a part of that. It is as if I am looking from one side. This is the diagram. This is the charge sheet. I am looking from one side. I want to find what is electric field nearby. When I give the charges are present on this side and charges are present on this side also. Both sides charges are present. Are there charges present here? Definitely, but we assume thickness is more. Here the area is larger, more charges on both sides. They are uniformly distributed. That means charges on this and charges on this will be almost same. I consider a point, example, at 50 centimeter on the right side, some electric field is there. 50 centimeter on the left side, some electric field is there. Since the charge is very large and distance is the same, the electric field at both places will be same. Look at that. I am looking from one side of the plate. I am looking from this side. So I can see, I will cover the diagram. So I stand here. So I consider a point here. Electric field will be positively charged, means away from that. Negative means towards that. I consider an equally distant point here. If this is 50, this is also 50. The electric field is away from that because it is what we call positive charge. If it was negative, towards that. Now, to utilize the Gauss theorem, we know the Gauss theorem is phi is q upon epsilon 0. There must be charge must be there and a closed surface is there. Our plane sheet is not a closed surface. It is an open surface, open everywhere. Closed surface, how to get? We consider a cylinder of area of cross section A, both area is going to be A and having some length. It is as if, it is just an imaginary case, it is as if the half of the cylinder is on left side and half of the cylinder is on the right side. Half on the left side, half on the right side. It is an imaginary thing, Gaussian surface. When we consider all this, we want a closed surface. So imagine I made a cylinder, half the cylinder is on this side and half the cylinder is other side. It is as if cylinder is cutting through this and going through. Imaginarily cutting through this. We have seen for the cylinder there are three ends. End, right hand side circular end, left hand side circular end and the curved surface. Now this is the area of the surface. We want to find what is the total flux passing through this. We studied earlier charge divided by area, we call sigma, we call it a surface charge density. What is sigma? Charge upon area. So Q is the charge, A is the area. Cross multiply, charge will be sigma into A. So how much is the charge in terms of sigma? Sigma into A, where A is the area. So in this area, in the shaded area, how much charges will be there? Sigma A. So our equation phi is Q upon epsilon 0. Q is sigma A upon epsilon 0. Why sigma? Because some area, so charges will be distributed over the area. Now I want to get the flux. Easier one, I look at the left hand side or right hand side also I can take. Right hand side, what is the area of the surface? This is the area A, but area vector I represent by the area vector will be perpendicular to the surface outward. So don't you feel E and A, the shaded area, circular end, in the same direction, theta is 0, cos 0 is 1. So what is the flux? E delta S cos theta equal to EA into cos 0 is 1. So flux is E into A. So one flux through this area is going to be E into A. Similarly, can you find what is the flux through this? Electric field is away from the surface to the left. Why not right? It is away from the surface. And what is the area vector? Area vector will be definitely outward. What is the angle between the two? 0. So what is the flux? E delta S into cos 0. Cos 0 is 1. So EA into 1. So flux here is, those who understood, I write, I hope you follow, E into A. It is not a vector. E is a vector, A is a vector. What is the flux through this also? E into A. So many flux means lines. So many lines, there is a 10 are there. 10 lines goes this side and 10 lines goes this side. That will be 10 plus 10, 29. What is the flux through this curved surface? We come across, if I am having a cylinder, this is the curved surface. The electric field is parallel to the surface. Electric field, my ruler is the electric field. This is the curved surface. My ruler is parallel to the cylindrical surface. My ruler is parallel to the curved surface. So what is the flux? Flux is going to be 0. What is the flux? Flux here is going to be 0. Otherwise, area of the surface, I represent it by a vector perpendicular to the plane outwards. This electric field will be in this direction. Angle is 90. So cos 90 is going to be 0. What is the flux? 0. So flux along the horizontal surface is going to be 0. Flux along the horizontal surface is going to be 0. So what is going to be the total flux? The total flux will be EA on the left side. Example, 10 lines are passing through that. Electric flux is the total number of field lines passing. Then EA plus the other one is going to be 0 along the surface, no flux. And the other end, it is going to be again E into A. So that is going to be 2 times EA is the total flux. Total flux is 2 times E into A. What is the electric field? What is the area? Area of the cross section. Area of cross section. Now in this case, if 10 lines are going this side, 10 lines are going this side, total is going to be 20. So anybody who feels 10 this side and 10 this side and they cancel and 0? No. Maybe in a room we are there, so 2 openings are there. Some 10 people have gone this side and 10 people have gone this side. How many have gone out? Shall I say 10 went this side, 10 went the opposite side, nobody went? No, 20 went, because it is not a vector. So total is going to be 2EA. Our last step, 2EA is going to be sigma A upon epsilon 0. A and A cancels. 2E is sigma upon epsilon 0 divided by 2. So E is sigma upon 2 epsilon 0 is electric field near an infinitely charged plane sheet. Electric field near an infinitely charged plane sheet. So have a surprising thing, E does not depend on distance R. E and the distance R, there is no relation. Is the distance R is coming in the diagram, in the equation? No. So whether the point is very nearby or little far away or little still farther away, electric field is the same. Electric field due to a charged plane sheet or plate does not depend on the distance. Last one point, what is the direction? To get the electric field is sigma upon 2 epsilon 0. To get it as a vector, I must multiply by a unit vector. We used to multiply by p cap or r cap. A unit vector perpendicular to the surface. Unit vector perpendicular to the surface. We write it as n cap. N stands for normal. Normal is perpendicular. Any notation, but the notation used in the textbook is n cap. Unit vector, n stands for normal, perpendicular to the surface. So I multiply by n cap, so the electric field will become in vector form. So what is the formula in vector form? E is equal to sigma upon 2 epsilon 0 multiplied by n cap E cap. E, not E cap, E vector. What is n cap? Unit vector in the direction perpendicular to the electric field. Conclusion: if the charge is, if it is positively charged, what is the direction? It is perpendicular to the surface, normal to the surface, outward direction. It is perpendicular to the surface, outward, or right in this direction. If it is negatively charged, last sentence, if it is negatively charged, can you say what is the direction? If it is negatively charged, it will be inward. If the charges are going to be negative, if I keep what is the direction of electric field? Inward. If I am considering here also what is the direction of electric field? Inward. So for negatively charged plate, it will be perpendicular to the surface, inward. Perpendicular to the surface, outward if it is positively charged. Perpendicular to the surface, inward if it is negatively charged. Only 2 more derivation remains. That means next day, day number 9, most of the theory part will be over. Study these 2 derivations. Bye till next time.